Tony, I want to ask you some more questions about global challenges and continue that line of questioning. What do you see in terms of on the technology side? Do you see any surprises coming in terms that are going to help us in terms of new technologies to deal with a world of increasing water scarcity?
Well, it's been a very interesting 30, 40 years of one's career, in that there's so many technological advances have been made. I remember in the early 90s being very excited because at that stage, Israel, which is a country which keeps good records and therefore you can track what has happened, had been through a crisis in '85, a drought, and they had to change the government, and so on. They had to change the water commissioner because someone had to be blamed. And so they decided to bring water use down. They used their government powers to regulate and limit water to farmers as well as to households. And it was going well, and it got down by '92 to pretty well where it was needed. That was to be at the 1961 levels, because this had happened, and so that was good. Then the gods sent a massive rainfall. All the water that had been overused since 1967 on the West Bank aquifers was put back in 3 weeks. So every water scientist in Israel, Jordan, Palestine, that moment when all the water that had been overused was just put back, it was life-changing, scientifically, emotionally, and so on. So they then, instead of keeping going and doing a bit more, the reservoirs were full, and what's the point of having full reservoirs if you need them to be half full to be filled up by the next season of rain? So they drifted back up. And at that point, but what they did put in was recycling. And I remember talking to a friend who was writing a book about it, and I was saying, Israel is the ideal laboratory to experiment to see how much water you can recycle from that which goes into.
You're talking about recycling municipal wastewater or agricultural return flows?
No. Urban water, municipal water, yeah. And I could see, well, potentially it could be 90%. But it's been a fascinating experience to watch it going like this. But now it's nearly 80%, and it will be 90%. It's been an extraordinary experience to observe that happen, to see the institutional, regulatory things that had to be put in place, as well as reorganizing and centralizing and so on. So that shows it's an experiment which every country that has a few big cities can in fact recover 80 to 90% of that water.
So there's no technological barrier?
No, it can be done. Having the right mix of city and urban and rural and so on is, as it happens, this surging population in Israel, it was 1.25 million in 1947. It's now 8 billion, 7.5, 8 billion. It's going to be 13 billion. I mean, it's an extraordinary thing. They've got to keep doing it. They've got to do more of it because, and that clearly shows that once you've got the water into the cycle, you're not going to be consuming. So the amount consumed is only sort of now 15% because the rest keeps coming back through. So that's a very, very important thing to know. It doesn't mean that a nation can become food self-sufficient. It just can be, makes it much more certain that urban water can be supplied once you put in the right technologies. So when they got to 2000, they found that they had back in trouble again because they'd gone back up, and the economists in the Ministry of Finance wanted to, no, we're not going to have desal, no, it's a waste of money, we've got to economize, squeeze a bit harder. And everyone in 1998 at a meeting said, yes, yeah, that's right, all the engineers, okay, 10 years, perhaps 20 before. But then the drought hits the next year as well. And so they changed the water minister and the prime minister, and they found it possible to send out the bids.
For the desal plan.
Yes, the invitation to bid for desal. And in came the number 56 cents, which was eye-watering.
56 cents per cubic meter for desal.
Yeah. Which, if you ask people in the room, how much do you pay for water, they don't know. But it's at least $2, and in this country it's about, to get rid of it, to get the water treated as well as provided, it costs about Well, now the dollar on the pound are the same. It costs about $4 or $5 a cubic meter, which you can imagine companies can make a living out of that. But so 56 cents is
10% for the raw water supply.
Because there are lots of extra costs from the gate.
Sure.
But nevertheless, 56 cents. They couldn't believe it. So they then have put in place a very ambitious desal program, which is producing more water than they need. But then, having said that, if you look over your shoulder, here comes the population going up. They will need. Looks as though they're now aiming for 750 MCMs, but they're ultimately expecting to need twice that much, and they feel confident about it. The only unfortunate downside of that is, of course, it's being the energy needed to produce the desal is not sustainable. So the dream, if you were to ask me what is the thing that we would really like to see, it is sustainable green energy producing desal water. And at that point, and some people are talking about 25 cents a cubic meter. You know from North America that farmers are prepared to pay that sort of...
A few,
yeah.
Very efficient California farmers. Most of them don't, but yeah.
So those two technologies are, the past 15, 16 years, they've been shown to be feasible, and they're not, one of them isn't good for the environment, but if people work on that, that will be very good, yeah.